Hi, Dr. Fox here. I want to demonstrate for you how to do chi-square analysis in Excel. It's also referred to as crosstabs or cross-tabulations, same thing. So when do you use chi-square analysis? You use it when you have variables that are a variable or variables that are categorical and therefore using count data. So in the first example here, did the number of students, this is our research question, number of students participating in visual arts this year per level of school match our expectations? So with chi-square, we're always looking at the observed, the actual numbers versus what we expected. And there's a number of different ways to think about and conceptualize the expected, but here's one way. So there were 45 middle schoolers who participated this year. We were expecting from historical trends that there would be about 50. How about high school students? 80 high school students participated in visual arts, but from the historical number, we were expecting about 100. So we have to create our expected values. You'll see a little bit later on, sometimes we calculate our expected values, and then sometimes we have to actually we determine what our expected values are going to be. That's what this one is. So the very first thing that I would do is I would highlight all of the data here, the whole table, go up to Insert. We want to get a visual on it. Click Recommended Charts. Let's do a bar chart. And here is the data right here. The very first thing I would do once we have this is we would change the title to Participation in Visual Arts by School Level, something like that. And you can see there's not a big difference between middle school. There is a little bit more of a gap here with the high school observed versus what we expected. You could do also other things like add a data table. You can add data labels. You wouldn't really do that necessarily. You can also, there are different ways to visualize it. You know, and they're also up here across the top. Okay, so that's our first thing. We visualize it, but then we need to ask ourselves, well, is there really, a difference there? Does our actual match our expectations? So to do that, we do a p-value, we calculate our p-value. So we hit equals CHI-SQ, and then we use this one down here, CHI-SQ.test. I double click, it's asking for the actual range, a comma, and the expected range. So the actual range is our observed, comma, and then our expected range is there. Close parentheses and hit enter. And our p-value is 0.034. It's less than 0.05, so there is a statistically significant difference there of what we observed versus what we expected. And again, based upon the visual, the 45 and also the numbers, 45, 50, okay, kind of close. 80, 100, okay, that's where the gap, that's where the difference is. It's in the high school. Okay, now let's move on. We have a few examples to look at. What if we have of the 45 middle school students, let's break it down. We're wondering if there are equal numbers of middle schoolers who were actually participating in visual arts this year. And what we found out is that there were 11, we counted them, there were 11 sixth graders, 11 seventh graders, and 23 eighth graders. Okay, well, how do we determine what our expected values will be? Real simple. Add up these numbers, divide by 3. What's the average of these three? So divide up the numbers, that's 45. 45 divided by 3 is 15. So we put 15 in each of these boxes here because we want to see, our question was, do equal numbers of 6th, 7th, and 8th graders. Another way to say that is there a relationship between participation in visual arts and grade level, middle school grade level? And then the third way to actually say the research question is there a difference between 6th, 7th, and 8th graders regarding participation in visual arts. So with chi-square, you can kind of conceptualize it and do it different ways. So same thing, equals chi-square and then test. So there it is right there. Double click on that. It wants the actual range and the expected again. Here's the actual, comma, here's the expected. Close the parentheses and hit enter. And it's 0.041. So there is a statistically significant difference. They are not equal. So 11, 15, kind of close. 11 and 15, kind of close. 23 and 15, it looks like our eighth graders outperformed our expectations. And obviously, we should have also done a bar chart to see, and we would have the data alongside here, and we could see that the observed in the 8th grade really outperformed what was expected. Not so much for the 6th and 7th grade. So our answer to that question is no. There aren't equal numbers of 6th, 7th, and 8th graders. There seems to be more 8th graders who participate in visual arts among the middle school levels. Okay, so that is chi-square goodness of fit. There's also another kind, a chi-square test of independence. When do we use chi-square goodness of fit versus chi-square test of independence? For these examples up here at the top, the goodness of fit, we have one variable, it's participation in the visual arts, and we have multiple categories, middle school and high school. Participation in visual arts, one variable, multiple categories, 6th, 7th, and 8th. What if you have more than one variable? Okay, now we have to use the chi-square test of independence. Yes, participation in the visual arts is still our overall variable, but we're looking at two specific variables. We're looking at gender and level of school. So we have two categorical variables that we're looking at. The very first thing that we have to do is to add our row totals and our column totals. And we do that simply by using the function. So I know the number is already there, but I want to save time. Equals SUM, double click, go up and grab the numbers, hit enter, and then, same thing, finish them out. And then you can add either the row totals or the column totals, one or the other, to get the overall sample size. So we had 110 110 students who actually participated in visual arts in the middle school and high school levels. Now, it does appear, let's do a quick visual on this. Recommended chart, the bar chart. And if we were looking at female versus male, we would say, oh wow, okay, we also calculated the p-value. There is a statistically significant difference in this. Let me back up. Disregard what I just said there. Let's do the visual. I'm trying to show you something specific here. So let's do the visual on this. It appears that there is a huge difference between females and male students. And if we did get a p-value that was statistically significant, we would immediately say, oh yeah, there's many more female that participated in the visual arts. However, let's not jump too quickly, because we only have our observed values. So I'm going to move this out of the way. We also have to calculate our expected values. And how do we do this? We don't base this off of like historical numbers. For this example, we actually have to use a formula. Here's the formula right here. It's the row total from over here times the column total divided by the overall total per cell. So let's do that. Equals, open parentheses, that's what we have here. So for the female middle school students, what's the row total? There it is right there. Times column total for female high school, female female middle school, the column total is right here. Close parentheses and divide by the overall total. Hit enter. Okay, we'll do this 3 more times. Let's look at female high school equals open parentheses, row total female high school is right there, times female high school column total right there, close parentheses, divided by overall total. And we'll do the same thing for the male. Equals open parentheses, row total for the male times column total for the male middle school, close parentheses, divided by overall total. And the last one is the high school male, so equals open parentheses, high school male row total times high school male column total, close parentheses, divided by overall total, enter. So now when we look at our observed values versus our expected values, okay, we had 41 females, but we were only expecting 37. Okay, let's go ahead and get rid of this. We had 41, we were expecting 37. So our female middle school students kind of outperformed. How about our male high school students? We had 8, but we were expecting 12. Uh-oh. Let's turn that some shade of red, okay? How about our female high school students? We had 41. We were expecting 45. We underperformed. And then how about our high school male? We had 20. We were expecting 16. They outperformed. So let's put the green. You don't have to put these colors to it, but it helps me realize, okay, it appears that our female middle school and our male high school outperformed expectations versus our high school female underperforming, as well as our male middle school students underperforming. So now that we have the observed and the expected, now we can calculate to see if there is a difference here. And we use the chi-square test, equals chi-square dot test. I'll do it again. Equals chi-square dot test. Here's our actual, comma, here's our expected, close parentheses, and hit enter. And we see the p-value is 0.04048. So there is a statistically significant relationship. So it appears, or difference, you can kind of conceptualize it both ways. Female middle school and male high school students did outperform expectations. And on the contrary, our high school female, we didn't have as many as we expected, and we had also fewer male middle school students. Okay, so this is where we can, do things like, okay, we need to strategize a little bit more. So kind of taking it the next step here, how can we get more middle school male students involved and more female high school students involved? Or what's keeping them from being involved? So this is a way to see if there's a difference between, again, actual versus expected. Okay, we're going to take one more step. This one's a little bit heavier. Now that we know that there is a statistically significant difference, now we have to ask ourselves, like the other types of tests that we've done, well, how big is that difference? And this may look just a little bit scary, but so I've brought everything down from above, so we're just continuing on. What we need to do now is we have to calculate these numbers right here. And we also have to calculate, we have to do a formula, because we're going to add all of these numbers here to get the chi-square test statistic. We need that number to determine our effect size. There it is right there, chi-square. So I know it looks like a lot, but I'm going to go ahead and delete this. And it's pretty straightforward, even though it looks complicated. What we have to do for each one of these boxes is do the observed minus the expected, square that, so in after close our parentheses, caret and 2. In Excel, to square a number, we hit the Shift and the 6, and you'll see right above the 6 key, the little caret. And this is going to square that number and then divide by the expected number. So let's do it. Equals, open parentheses, and we'll start with the female middle school, observed minus expected, close parentheses, Shift 6, that's the caret, square it, and then divide by the expected, and hit enter. These numbers really don't mean much to us. We just have to add all them up to get our chi-square test statistic. So equals, open parentheses, observe minus expected, close parentheses, caret 2 divided by expected. Enter. Equals, open parentheses, observed minus expected, close parentheses, caret 2 divided by expected. Enter. The last one, equals, observe, oops, I forgot the parentheses, observe minus expected, close parentheses, caret 2 to square it, and then divide by expected. Enter. So now that we have that information, let's move this over, move this up. To get our chi-square, we sum all of the numbers here, sum all above from our formulas there. So we hit equals SUM, double click on that, and just highlight all of them and hit enter. So 3.88. Our actual sample size we can get from the overall total. So it was 110. So we can put 110 in here. Now from the rows above, how many rows were there? There were 2. How many columns were there? There were 2 columns of data. And for our Q, which we need down in our formula, we take the smallest of these 2 numbers. Neither one, they're equal, so it's just 2. If we had, for example, 3 rows and 2 columns, then we would use the number 2. Okay. Our degrees of freedom is the number of rows minus 1 times number of rows minus 1. We could do that in our head. Number of rows minus 1 is 1. Number of columns minus 1 is 1. 1 times 1 is 1. So our degree of freedom is 1. For our p-value, I wanted you to see that if you have your chi-square value and you have your degree of freedom and you don't have anything else, you can actually do a p-value. So you can do that by using the chi-square dist RT, or you can just do equals chi-square dot test. But let's do it this way just to show you. Equals chi-square dist RT, and what it's asking for is the chi-square and the degree of freedom. Chi-square, comma, degree of freedom. Close parentheses and hit enter. That's the same number as over here. It's just, and we used a different formula. So let's calculate our Cramer's V. Equals square root, SQRT. The next thing that we need is an open parentheses, which it's there. Next we need the chi-square test statistic. There it is right there. And the next thing we need is divided by, and then we open parentheses. The n is right there. And then we multiply. We open parentheses again. And then the q minus 1. And then we close all three of our parentheses and hit enter. Okay, and we have the Cramer's V effect size right here. If we look at our key, we go down 0.188. Is it less than 0.1? No. Is it less than 0.3? Yes. So it's a modest effect size difference there. And we already stated this is where our difference lies. I know that's a lot to get our Cramer's V, but that's what we have to do in Excel. So for the practice, we have a goodness of fit here. So just calculate the p-value and then also do a visual using the bar charts. And then I'd also like for you to just interpret it using 2 or 3, maybe 2 sentences, 3 sentences to interpret the data. Here's our observed, and this is what we were expecting from our last 5-year average. And make sure you read the whole research question here so that you can write up your 2, 3, 4 sentence findings. You don't have to do effect size. I won't make you go through all that. Chi-square test of independence, same thing. Read through the research question. Here's the observed data. You have to do the row total, the sums, and then you do your expected values here based upon that calculation. And then you do your p-test, your expected values and your observed values and your expected values. Same thing, you can visualize this if you want to. I won't go into doing clustered bar charts and so forth at this point, but anyhow, also you can write a 3 or 4 sentence findings. Okay, if you wanted to practice using the Cramer's V effect size, if it is statistically significant, then by all means go over here to the demo, copy and paste all of this over to here, and work through it if you want. It's up to you. And then in practice 3, create one of your own. Think about something maybe in your school setting, your classroom setting, or just make up data, and you want to develop a research question that requires chi-square analysis, and then write a short description of the findings, also create a graphic, and you can do either a chi-square goodness of fit or a chi-square test of independence. Hopefully this is helpful to you, and blessings.